welcome to the Deep Dive. Today we're looking at, well, a bit of space history coming back to haunt us, you could say.
Yeah, it's this old Soviet Venus probe, Kosmos 482. It's expected to re-enter Earth's atmosphere pretty soon.
And we've been looking through a report from Eurasia Times to get the key details for you.
It's fascinating because it connects directly back to the Cold War space race, but now has this very real-world potential consequence, however small.
Right, it's not just history.
Yeah.
So let's set the scene a bit. The Cold War, U.S. versus Soviet Union and space was, well, a major battleground.
Absolutely. And part of that was the Soviet Venera program, Venera, that's Russian for Venus. They were really focused on exploring Venus.
An incredibly ambitious goal, especially back then.
Hugely ambitious. We're talking flybys, atmospheric probes, and even landers, trying to get hardware onto the surface of Venus.
Which is just incredibly difficult. The heat, the pressure.
Extreme.
Yeah.
Absolutely extreme. But they had some remarkable successes. The Venera missions actually confirmed Venus's atmosphere is mostly carbon dioxide, found traces of sulfuric acid. Wow.
Yeah, and they got temperature and pressure readings from the surface. And maybe most impressively, they managed 7 successful landings on Venus.
7, compared to how many U.S. landings designed to survive.
Well, the U.S. probes sent around that time weren't really designed for surface survival in the same way, so 7 Soviet successes in that specific aspect.
Still, a massive achievement given the technology. But obviously not every mission went perfectly.
No, definitely not. And that brings us to Kosmos 482, launched March 31st, 1972.
Part of the Venera program, same goal. Get to Venus, land, send back data.
Exactly. Temperature, pressure, atmosphere composition. It was pretty much identical to Venera 8, which actually did succeed later that year.
Okay, so what was this thing like? The Eurasia Times piece mentioned its weight.
Yeah, about 11,184 kilograms at launch. It had the main spacecraft, the carrier bus, and then the descent module, the lander itself.
The lander was the bit meant to actually go through the atmosphere. Right. It had a top shell designed to be jettisoned, then a parachute would deploy. It was all battery-powered for the landing sequence.
But it didn't quite make it to Venus, did it?
No. It never left Earth orbit. After reaching a temporary parking orbit around Earth, the next engine burned. Well, it didn't burn long enough.
So not enough oomph to escape Earth's gravity and head towards Venus.
Precisely. A technical failure. And because of that incomplete burn, the spacecraft actually broke up.
Broke up. Into how many pieces?
4 main chunks, apparently. 2 of them fell back to Earth and burned up pretty quickly back in '72.
And the other 2?
They got pushed into a higher, more stable orbit, and it's one of those pieces that's now making its way back down.
And this whole Kosmos name,
Yeah.
that was standard Soviet practice for failures, right? Hide the intended mission.
Yeah, exactly. If an interplanetary mission failed to leave Earth orbit, it would often get a generic Cosmos designation. Kept things, under wraps during the Cold War. Very secretive.
So this failed Venus probe just became another number in the Cosmos catalog.
Pretty much. Its real purpose only became widely known later on. But now, over 50 years later, it's coming back.
And soon, according to the Eurasia Times report, they're estimating sometime between May 9th and May 11th.
That's the window, yeah. But as they point out, predicting these things precisely is tough. Space weather, atmospheric drag, it can all shift the timing.
Has anyone actually seen this thing recently?
Yeah, there are experienced satellite watchers like Ralph Vandenberg. He's actually managed to image it. He described seeing a spherical shape, which is probably the lander module.
The bit designed to survive entry.
Exactly. And then some kind of trailing structure, maybe the parachute housing or an antenna. He's seen it before, back in 2014, and his recent images confirm it. Says it's way closer than, say, a Starlink satellite.
So the consensus is it's likely the descent module, the tough part. That's kind of down, even if there's some uncertainty.
That seems to be the prevailing view, yes, because that's the part built to take the heat. And it's not small. We're talking around 500 kilograms, half a ton.
Okay, 500 kilos. So the big question, what happens when it hits the atmosphere? Does it just burn up like most space junk?
Well, that's the tricky part. Normally, yes, the friction and pressure are immense. Things disintegrate.
Right.
But Cosmos 482's lander has that heat shield. It was designed for Venus, which is, way harsher than Earth reentry, so there's a chance, a real possibility, that a significant chunk could survive.
Because of the Venus-proof design. Huh. Any idea how fast it might be going if it does make it through?
One scientist, Marco Langbroek, estimated it could hit the ground at maybe 242 kilometers per hour, assuming it stays largely intact.
That sounds significant. What's the actual risk assessment, though? Should people be worried?
Langbroek puts it into perspective. He says the risk is comparable to being hit by a random meteorite, which does happen, but it's rare for any specific person. He even said you're more likely to be struck by lightning.
Okay, that helps frame it. So statistically, very low risk to any one person.
Very low. But, the report is clear. It's not zero. It could hit something or someone. It's just very improbable.
And the potential impact zone is huge, right? The report listed continents.
Yeah, vast areas: Africa, South America, Australia, parts of the U.S., Canada, Europe, Asia. Basically, a huge swath of the planet. Pinpointing it now is just impossible.
This isn't the first time old Soviet gear has come down uncontrolled, is it?
No, not at all. Eurasia Times mentioned a few others. Cosmos 96, also meant for Venus, had bits land in Pennsylvania back in '65.
Really? Pennsylvania?
Yep. And even parts of this mission, Cosmos 482, apparently some smaller pieces landed in New Zealand right after the initial failure in '72.
Huh?
And then there's the big one, Cosmos 954 in 1978. That was a nuclear-powered spy satellite that crashed in northern Canada. Caused a big international incident, understandably.
Right, the nuclear aspect. Now, Cosmos 482 had a parachute, didn't it? Any chance that might deploy?
It was designed with one for Venus, yes. But after, 53 years in space, the radiation, the vacuum, the odds of it working now are, vanishingly small. Extremely unlikely.
So don't expect a gentle landing.
Definitely not.
Okay, so let's recap. We've got this Soviet-era Venus probe, Cosmos 482, failed back in '72, now making an uncontrolled return to Earth sometime very soon.
Right. A piece of Cold War space race history literally falling out of the sky.
And while the direct risk seems very low, maybe comparable to a meteorite strike, it's not zero because that lander module was built tough for Venus.
Exactly. And it really makes you think, doesn't it, about all the stuff we've launched up there over the decades.
Yeah, the sheer ambition of those early programs, but also the debris, the long-term consequences we're still dealing with.
For you, following these kinds of developments, maybe especially if you're looking at things from a current affairs or even a civil services perspective like UPSC, this story touches on a lot. Space history, technology, risk assessment, international implications of space debris.
It's a reminder that space isn't just out there. What goes up can eventually come down, sometimes decades later. It really underlines the need to think about space traffic management and debris mitigation moving forward.
Absolutely critical. As space gets more crowded, these issues become more pressing.
So if you found this deep dive into Cosmos 482 interesting, and you appreciate understanding the history behind current events, please do give us a like and subscribe for more discussions like this.
And definitely leave your comments or questions below. We do read them, and it helps shape future topics.
And we should mention again, our source for the core information today was the Eurasia Times.
So maybe a final thought to leave you with. As we look at this relic of the past returning, what lessons does it really hold for our future in space? What can we learn from these early, ambitious, sometimes flawed attempts as we keep exploring?
A really important question. Thanks for joining us on the Deep Dive.